On February 2nd, 2010, the U.S. Treasury estimated the national debt at 1.2278 times 10 to the 13th power. And just to get a sense of things, 10 to the 6th, you're talking of 1 times 10 to the 6th is a million, 1 times 10 to the 9th is a billion, 1 times 10 to the 12th is a trillion. So we're talking about on the order of magnitude of $10 trillion. So this is about $12 trillion. Then they tell us that the U.S. Census Bureau estimate for the U.S. population was about 3.086 times 10 to the 8th power. So this is a little over 300 million people. So that's an interesting number right there. It's the population. And then they say, using these estimates, calculate the per person share of the national debt. So essentially, we want to take the entire debt and divide by the number of people. That'll give us the per person share of the national debt. Use scientific notation to make your calculations and express your answer in both scientific and decimal notations. All right, which means just as a regular number. Round to 4 decimal places while making calculations. So we want the per person debt. So we want to take the total debt, divide by the number of people. So the total debt is 1.2278 times 10 to the 13th power. And we want to divide that by the total number of people. The total number of people, which is 3.086 times 10 to the 8th. And we could separate this into 2 division problems. We could say that this is equal to the division right here. These guys, 1.2278 divided by 3.06. So 1.2278 divided by 3.086. And then times 10 to the 13th divided by 10 to the 8th. Now what's 10 to the 13th divided by 10 to the 8th? Let me do it over here. 10 to the 13th over 10 to the 8th. The way I think about it, this is the exact same thing. This is equal to 10 to the 13th times 10 to the negative 8, right? 1 over, this is an 8 right here. If you have a 10 to the 8th in the denominator, that's like multiplying by 10 to the negative 8. So you have 13, you have the same base 10. So 10 to the 13th times 10 to the negative 8 is going to be 10 to the 13 minus 8, which is 10 to the 5th. Or another way to think about it, if you have the base in the denominator, you subtract the exponent. So it's 13 minus 8, 10 to the 5th. So it's this blue expression times 10 to the 5th. 10 to the 13th divided by 10 to the 8th is 10 to the 5th. 10 to the 5th power. And let's get a calculator out to calculate this right here. Let's get the calculator out. And they say round everything to 4 decimal places. So I'll keep that in mind. So let me turn my calculator on. 1.2278 divided by 3.086 is equal to 3979, because we want to round right there, 4 digits. So 3979. Let me remember that. Or let me just put it on the side. Let me put it on the side so I can still look at it. So this little dividing decimals problem results in, this is 0.3979, and of course times 10 to the 5th. Times 10 to the 5th. Dollars per person. Now, once again, you might be tempted to say, hey, this isn't scientific notation. I have some number times a power of 10. But notice, this number is not greater than or equal to 1. Remember, this number, if you want to be formal about scientific notation, has to be greater than or equal to 1 or less than 10. So what we can do here is we can multiply. If we don't want to change the number, we can multiply this number by 10 and divide this number by 10. Or another way you can think about it is, this whole thing can be rewritten as 0.3979 times 10 times 10 to the 4th. Times 10 to the 4th. What I did just now is I broke up the 10 to the 5th into a 10 and a 10 to the 4th. And 10 to the 4th. And I did that because I want to multiply this by 10 so I can get a 3 out front instead of a 0.3. So let's do that. So if you multiply this out, so essentially I took a 10 out of the 10 to the 5th. I divided it by 10 and I multiplied this other guy by 10, not changing the whole number. So then this right here will become 3.979 and then times 10 to the 4th. Times times 10 to the fourth power. So that's how much debt there is per person in scientific notation. So this is debt per person in scientific notation. Now, in the problem, they also wanted us to express it in decimal notation. Which is just kind of standard, writing it as a number with our standard numeric decimal system. So what is 3.979 times 10 to the fourth? So let's think about it. We have 3.979 times 10 to the fourth. Or let me just do it this way, times 10 to the fourth. So if we multiply it, let's just move the decimal space. If we multiply it by 10, we're going to get 39.79. If we multiply it by 10 squared, we're going to get 397.9. If we multiply 10 to the third, we're going to get 3,979. If we multiply it by 10 to the fourth, we're going to get one more 0 right there. So we're essentially going to move the decimal 4 to the right, and we get, it's 39, so I could write it like this. This is equal to $39,790. So if you think about the national debt per person, every man, woman, and child in the United States essentially owes $39,790.